All right, today we're going to look at bonding day 1 notes. Yes, we did start chapter 8 with looking at electronegativity, and then we looked at some definitions for bonding, but now we're going to look at specifically drawing bonding of these actual molecules. So we're just going to recap. Remember that atoms are going to share electrons in a molecular covalent bond, but it doesn't mean that they have to be sharing equally, right? So if the electrons are distributed equally around the molecule, right, when you join more than one atom, that is called nonpolar covalent, NPC. But if there's one side that is pulling the electrons more, so in this case the left side is pulling more, that's going to be polar covalent. And we showed the notation, right? So if they're sharing pretty much equally between 0 to 0.39, we just draw a straight line to connect them. But if they are polar covalent, I have to draw a dipole. And in this chapter, I'd like for you to draw it in a different color. And you're going to point the arrow to the side that has a higher electronegativity. And if it's ionic, you put a plus or a negative sign above the ions the atoms, but you don't connect them. The one that is more electronegative has the negative. The one that's lower in electronegativity is positive. So that's how we note the difference in how the electrons are being shared or not shared, right? So then on the last day before break, we looked at some definitions. So we know the idea that all atoms want to have 8 electrons. They want to have their full outer shell full of electrons, 8, except for hydrogen and helium because they can only have 2. We learned that a single covalent bond is a sharing of 2 electrons, and when 2 atoms are sharing electrons, right, we want to make sure we change that into a straight line, which represents 2 electrons, 1 pair. Unshared electrons are not connected because they're not being shared with another atom. They are non-bonded pairs of electrons. If we have 4 electrons being shared, that's 2 pairs. If we have 6 electrons being shared, that's 3 pairs. Remember, there's no such thing as a quadruple bond, so we don't have that. We're going to start drawing Lewis structures that show the representation of molecules with all the electrons bonded and non-bonded. So then what we did is we looked at the elements on the periodic table. Remember, this chapter should only be dealing with elements to the right of these imaginary stairs. And so we can look at patterns, right, because these are the elements that are at the top of each group on the periodic table. Hydrogen, right, is here, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. We said that carbon likes to have 4 bonds. You need to know that for the test. It likes to have 4 bonds because it needs 4 more from the 4 that it already has to have 8. So it usually looks like this, right? Each line represents 2 electrons being shared. We talked about how nitrogen has 5, and it likes to have 3 more to get 8. Oxygen 6, 2, 7, 1. And the neon, all the noble gases are okay. Could there be bonding of noble gases? Of course, but you're going to see that in AP Chem. I did say that boron and beryllium are exceptions. I said be careful with the B's. And the reason why is because boron is technically a metalloid and beryllium is a metal. So why are they in this chapter? They're so small that they can act like non-metals and they share their electrons. Big thing before we look at drawing, right? We said that hydrogen can only be attached to one thing. Either the hydrogen is going to be attached so it's on the right or on the left, but we can never put it in the middle to be considered a central atom because this would mean that hydrogen has 4 electrons and the most it can have is 2. Same thing with the halogen, right? Anything that's in the same family as fluorine, so F, Cl, Br, I, At, those are only going to have 1, right, electron being shared with another atom, and they will never be a central atom because they only need 1 more to have their octet. So now we're moving on to the next page, and these are technically the rules for how to draw the structures. You're going to find the sum of the valence electrons for all atoms in the polyatomic ion or the molecule. So we're going to start looking at polyatomics tomorrow. Connect the outer atoms to the central atom with a single bond. The central atom is the least electronegative element that isn't hydrogen. So if I'm looking at a periodic table, right, you can use your pink one or you can use the one from the front page of the notes. Remember, this has 1 valence electron, 2 valence electrons. This one has 3, 4, 5, 6, 7. And then the noble gases aren't on this one, right? And so now it says we need to find the sum of the valence electrons. So we're going to figure out where the element is on the periodic table. We're going to connect the outer atoms to the central atoms with a single bond. So I have to figure out which one goes in the middle. And the one that goes in the middle is the one that is least electronegative. So it's usually Be, B, C, N, then O, but it's never going to be H or halogen. You're going to fill the octets of the outer atoms and then fill the octet of the central atom. Check to see if all atoms are happy. Do they have all 8 or 2 electrons? 2 would be for hydrogen and helium only. If you run out of electrons before the central atom has an octet, form multiple bonds until it does. If you have extra electrons, place them as lone pairs on the central atom. Last step, always check to see if atoms are happy. All right, and so what does that mean? We're going to look at this process, but this is what is going to drive us today. You have to make sure you know these steps. So I would encourage you to maybe take a picture of this on your phone and then make sure that you're looking at your phone, this page, right, as you're looking at filling in these notes. I always like to give you an idea of what you should expect, right? So drawing the structure correctly is worth 2 points. If the structure has resonance, that's going to be worth 1 point. All the other structures connected with arrows are half points. The shape, drawing it correctly, is going to be worth 1 point. If it's a polyatomic and ion, you're going to have to put brackets and charge. That's going to be worth a point. Dipoles are always worth 1 point. So these are all the possibilities, right, that you could be graded on. Now, you don't know what resonance is. You haven't learned shape. We haven't done polyatomic ions. But what you should notice is that structures are worth 2 points and dipoles are worth 1 point. So we're definitely looking at these on day 1. So structure and dipoles. All right. So now we're going to start with the first example. And I cannot stress this enough. This is going to seem so easy or much easier when I'm doing these problems with you. All right. So it is important, right, that you follow along and make sure that you understand this concept so that you're not struggling when we get to day 2, right, which will be the following day. All right, so the first thing is it says find the sum of the valence electrons for all atoms of the polyatomic ion or molecule. Okay, so H2 means that the different types of elements in here are hydrogen, right? And what we're going to do is take the number of atoms and we're going to multiply by the number of the valence electrons. Okay? So we're going to take the number of atoms and we're going to multiply by the number of valence electrons. If you're not in pencil, you definitely want to switch over to a pencil. So you definitely are going to do these problems in pencil. So hydrogen, right? The number of atoms, that has 2. Okay? So actually, I'm going to put this in a different color so that you know where these are coming from. So there's 2 here, times the number of valence electrons. Well, remember, hydrogen is in this first column, so it has 1 valence electron. So we have 2 times 1. So remember, we took 2 because there are 2 atoms of H and there's 1 valence electron because it's in group 1. So 2 times 1, so we multiply, right? 2 times 1 is 2. So we did step 1. Find the sum of the valence electrons for all atoms in the polyatomic ion or the molecule. We did that. Connect the outer atoms to the central atom. Okay, when you only have two things, the only way to connect them, right, is to, right, write them straight across. So that's going to help us, right? So why did I draw two H's? Because there's two here, right? So now it says connect the outer atoms to the central atom with a single bond. So I did that. H and H, right? So now, how many did I have available? I had two. So I try to keep track of my electrons here. There's two available. Do we agree that this straight line uses up 2 electrons? Because each straight line represents 2 electrons. So I've already used 2. I have 0 left over, so I'm technically done. I can't share more electrons than what I have. So the next thing is I don't need to do 3 or 4 because I am pretty much done. But here it says last step, always check to see if atoms are happy. Okay, remember, if the atoms are happy, they should have 2 electrons for hydrogen and helium. They should have 8 electrons for all other atoms that are not exceptions. So like not beryllium or boron. Okay, so let's see. H. Now remember, this straight line means that it belongs to, these electrons belong to this one and this one. So 1, 2, happy. 1, 2, happy. Okay, so this is the structure. I like to check that they are happy. That's not something you have to do, but that's what I like to do just to make sure I don't forget. Okay, so now we move on to looking at the last column, which is bond type. So I'm going to pick to put my bond type in this pink color. So I'm going to note that if it's polar covalent, I use this pink color to represent the dipole. Okay, so that's what I'm going to use. But then here, right, if I take 2.20, right, 2.20 minus 2.20, I just subtract those two, right, to see what they are. It's 0. Excuse me. So that is non-polar covalent. So remember, on the first day of notes, if it's non-polar covalent, all I do is show a bond between the atoms and I don't put an arrow. So all I have to do is say is that it's non-polar covalent, and that is my structure. Now we're going to move on to F2. Once again, find the sum of the valence electrons. So I'm just following the notes on page 3. If you took a picture of it, then you're following it on your phone, right? Find the sum of the valence electrons for all atoms in the polyatomic ion or a molecule. So I go ahead and I look, right, at F. I know that there's 2 F's, okay? But now I have to figure out the number of valence electrons. So I look for F, which is this one here, right? F is in group where there's 7, so it has 7. So I put a 7 there. 2 times 7 is 14. So we have 14 available to use, right? So now we're on step 2. Connect the outer atoms to the central atom. When I only have 2 things, right, because I have 2 F's, F and another F, right, the only way to attach them is to put a bond between them. There's no central atom because there's only 2 things to attach. All right. Now, when I use this straight line, though, I have used 2 electrons. So 14 minus 2 is 12. So now I have to go to step 3. Fill the octet of the outer atoms. Okay, so remember, for each atom to be happy, it needs 8 on each atom that are not hydrogen or helium. So it already has 2 here. So 1, 2, 3, 4, 5, 6, 7, 8. Now, how many more did I use? 1, 2, 3, 4, 5, 6. So I have 6 left. And you might say, well, there's exactly 12, right, that we had after we used the 2 in the middle. I'll just put 6 more on this one. And that gives us 0. So I have filled the octet of the outer atoms. There was no central atom. So now I just move on to the last one, which is always check to see if all atoms are happy. So I've used all available, right? Remember, I'm using the ones that I start with, which are the available. So let's see if each atom is happy. I don't have H or HE, so all of them should have 8. 1, 2, 3, 4, 5, 6, 7, 8. Happy. 1, 2, 3, 4, 5, 6, 7, 8. Happy. So this is the correct structure for F2. Now, I have to look at if it is polar covalent or nonpolar covalent. Now, I have been very nice and I put the electronegativity so you don't have to look them up, but one F, right, is 3.98. Another F is 3.98. I subtract those to figure out the electronegativity. That's 0. So this is also nonpolar covalent. I don't draw a dipole. I only draw dipoles for polar covalent. All right. Now I'm moving on to HBr. So for HBr, right, I have H and I have Br. And if I need to, right, I'm going to put that there's one of each one. There's one H, there's one Br. So 1, 1. Remember, the available come from what group it's in on the periodic table. H, 1 valence electron. Br is in this group, 7 valence electrons. So this is 1, this is 7. I am going to follow my steps here. Number 2 says connect the outer atoms to the central atom with a single bond. The central atom is the least electronegative. Once again, there's only 2 atoms. I just have to write them straight across. H and Br, and I have 8 electrons to work with. So I put that straight line that has 2. 8 minus 2 is 6. Okay, now what I'm going to tell you, right, is students are like, oh, 6. I'm going to go ahead, right, and start putting dots here. But remember, H. Once H is attached, it can only have 2. So you need to learn to just check that, because you never, ever, ever can put dots. You can't do that. You can't say, oh, well, this H needs this. No, because remember, it can only hold, right? It can only hold 2 electrons. So the H is just an H. So this one's happy. I check it. I leave it alone. But I still have 6 electrons to work with. Well, I can't put them on this H. Let's see if they fit here. 1, 2, 3, 4, 5, 6. They fit, right? So I have 0 left. Now I got to see if it's happy. 1, 2, 4, 6, 8. Yes. And that is the structure for HBr. Now, though, what I'm going to do is look at its polarity. 2.20 minus 2.96. I subtract those 2, and I get 0.76. Now, remember, according to our notes on day 1, right, if it's between 0.40 and 1.99, it is polar covalent. So because this is greater than 0.40 but less than 1.99, it is polar covalent. And I'm going to draw the dipole towards the one that's more electronegative. Well, H is 2.20, Br is 2.96. I'm going to draw that arrow towards the Br. So that is what the structure should look like. Remember, these numbers come from here on the electronegativities. I have written them here, though, for the notes to make it a little bit faster to get through. All right, the next one, CCl4. So I have carbon and I have Cl. The number of atoms, this one has 1, this one has 4. 1, 4. I multiply by the number of valence electrons. So carbon, right? Group 4 has four available electrons, so 4. Chlorine has 7. 4 times 7 is 28. Now, I cannot stress enough that students are great at drawing structures, like once they know the rules. They're awesome at drawing. But what they do is they make mathematical mistakes, and there's nothing that I can do other than tell you that you have multiplied or added incorrectly. So, if I accidentally say that 4 times 7 is 24, that's really going to throw off my calculations. So if you feel like something's not working out, go back and check your math, okay? So 28 now plus the 4 is going to give me 32. So I have 32 electrons to work with. So now, right, I did step 1, which is find the sum of the valence electrons in the polyatomic ion or molecule. 2, connect the outer atoms to the central atoms with a single bond. The central atom is the least electronegative. So C is 2.55, Cl is 3.16. So I'm going to go ahead and put a carbon in the middle. That is my central atom. Now, I have to attach 4 Cl's. So how do I do that? First, I have to draw correctly that there's 4 of them. 1, 2, 3, 4. If I attach these to the C, right, how many electrons have I used? 1, 2, 3, 4, 5, 6, 7, 8. So I have 32 minus 8. 32 minus 8 is 24. So I have done steps 1, 2, right? And then now I'm going to fill the octets of the outer atoms. So 1, 2, 3, 4, 5, 6. Why did I draw 6 here, right? Because it already has 2 here. And if it wants a total of 8, right, I'm going to have to put 6 electrons on each one. But what you notice, right, like if there's 4 things attached and there's 24 electrons, 24 divided by 4 is 6. Can I put 6 on each Cl? Yes. So that's exactly what I'm going to do. And that is my structure, right? Now I have 0, okay? And then I see if everybody's happy. Carbon, 1, 2, 3, 4, happy. Cl, 2, 4, 6, 8, happy. 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 So everybody's happy. All right? This is the structure for CCl4. The next thing is it nonpolar covalent or polar covalent? So what I have to do is subtract these two. So I take 2.55 minus 3.16, which gives me 0.61. So I look here, right? It is definitely greater than 0.40. So it is polar covalent. I have to draw a dipole. The dipole is going to point towards the one that's more electronegative. So let's see here. This is polar covalent, and the dipole is going to go towards the Cl. But how many CCl bonds do we have? Well, I have this one to here, right? So I'm going to draw this one with the arrow up, this one with the arrow down, this one to the arrow with an arrow to the right, arrow to the left. So you can see that it starts to get a little crazy, and that's why I want you to show it with different colors. Okay? So now, what compound will form with nitrogen and hydrogen? Here, I didn't tell you how many you have. So there might be more than one answer. But let's go ahead and figure out how many available electrons there are. So N and H. Right? So I don't know how many N's and H's I have. All I know, right, is that if I had one N, right, and one H, I know that the available electrons, N, would have 5, and hydrogen only has 1. Okay? I don't know how many I need, But I'm just going to go ahead and try to figure it out. So N has 1, 2, 3, 4, 5. Now, if I put 1H, that could go here. That takes care of that one. But I still have a hole here and a hole here that I need to fill in with the electrons. So then what that means is I would add another H here and another H here. But what does this actually look like? This actually looks like, I'm going to redraw this over here because I ran out of space and I want to be able to show you what it looks like with the actual bonds. So it's going to look like this. H, attached, right, to 3 H's attached to the N with 1 lone pair. All right. So once again, this is you predicting what would be a good molecule for this structure. This doesn't necessarily mean that it's something that you have to know how to do like on the test. I just want to see what you figure out, okay? I always have questions of, does it matter if I put the H down here or up here, like where my lone pairs are? No. You just have to have the H's attached and 1 lone pair on the end. So now I have to figure out if it's nonpolar covalent or polar covalent. So I'm going to subtract these. 3.04 minus 2.20 is 0.84, which means that it is polar covalent. It's going to go towards the one that is more electronegative, between 3.04 and 2.20. This one's more electronegative, so it's going to point towards the N, right? This one pointed towards the Cl. This one pointed towards the Br. Okay? So now what I'm going to do is look at pointing the dipoles towards the N. And so that's what that structure would look like. Now we're going to do the next one, which is dichlorine monoxide, Cl. There's 2 of them. The O, there's only 1, right? Remember, those numbers come from here. And then I look at my periodic table. Cl is in this group here, 7. O is in this group here, 6. 2 times 7 is 14. 1 times 6 is 6. 14 plus 6 is 20. So I've done step 1. Find the number of valence electrons in all available atoms in the structure. So I did that. Okay? Next step, connect the outer atoms to the central atom. All right, now we want to figure out which one we should put in the middle. Ideally, we want to put the least electronegative element in the middle, which would technically be Cl in this case. But the reason why it's O is because O, right, can be connected to 2 Cls. So usually, if there's only one of that actual element, you're going to put that one in the middle. So I'm going to try with putting the O in the middle and then put Cls attached. So I have 20 minus, right? I've used 1, 2, 3, 4. 20 minus 4 gives us 16. So now I move on to step 3. Fill the octets of the outer atoms. Outer means the outside ones. So I'm going to fill this one and this one. So I have 1, 2, 3, 4, 5, 6, and then there's 7, 8 there. So how many did I use? 2, 4, 6. I have 10 left. 1, 2, 3, 4, 5, 6, and then there's the 2 there, so that makes it 8. I use 6, so I have now 4 left. I did steps 1, 2, and 3. Step 4 says fill the octet of the central atom. I have 4 left. 1, 2, 3, 4. Now I have 0. I've used them all. Now I got to check if everybody's happy. 2, 4, 6, 8, happy. 2, 4, 6, 8, happy. 2, 4, 6, 8, happy. So everyone's happy. Now I got to figure out electronegativity differences to see if it is nonpolar covalent or polar covalent. This is 0.28. 0.28 is less than 0.40, so it is nonpolar covalent. I don't draw a dipole. Let's look at O2. O2, right? Remember, there's 2 here. So O2 times O has how many valence electrons? 6. 2 times 6 is 12. So I go ahead and there's no central atom because there's only 2 things attached. So there's O, and I started with 12. Connect them. Minus 2 is 10. So now step 3 says fill the octet of the outer atoms. And something I didn't really tell you at the beginning, but you should start to get into the habit of, is kind of draw your electrons lightly. So I'm going to fill in these, right? 1, 2, 3, 4, 5, 6. 10 minus 6 is 4. I have 4 left. 1, 2, 3, 4. Now I have 0. I've used them all, right? And the last thing I have to do is see if everybody's happy. So check to see if all atoms are happy. Do they have all 2 or 8? If you run out of electrons before the central atom has an octet, form multiple bonds until it does. Okay, that's where we're at, right? If I look at this, right, I'm going to see if everybody's happy. 2, 4, 6, 8, happy. 2, 4, 6, not happy. Okay? These are molecules. They have to share electrons. And they're going to share electrons until they're happy. So the reason why this works is because what they can do is whichever atom has more electrons can say, hey, I have electrons. I can just share more of those electrons. So right now, this oxygen isn't happy, but this one is. Whichever one is happy will share its electrons. So if you run out of electrons before the central atom has an octet, form multiple bonds. Happy, not happy. So what I have to do is the one that is happy is going to share more electrons. So what I'm going to do is take these electrons and move them in here. So I erase these and erase them well, right? Because I have to grade these structures and I got to be able to tell which ones have dots and which ones don't, okay? So now I have my double bond there. And don't worry too much about where your dots are. Like this one, it's on the left and on the bottom. This is top and bottom, right? But now this one was already happy. Let's see if this one's happy now. 2, 4, 6, 8, happy. And this is the structure of O2. This is our double bond, okay? Now to see if it's nonpolar covalent or polar covalent, I subtract. I get 0, nonpolar covalent. I don't draw a dipole for that. Moving on to CO2. Carbon is 1, oxygen's 2. So carbon, there's 1. Oxygen, there's 2. Figure out the valence electrons. Carbon has 4. 1 times 4 is 4. Oxygen has 6. 2 times 6 is 12. 12 plus 4 is 16. So I have 16 available. The least electronegative atom, C, N, and then O. And then I start looking at electronegativities, right? So carbon's going to go in the middle. And I'm going to connect 2 O's. So 16 minus 1, 2, 3, 4 gives me 12. So now, right, I've done step 1, step 2. Now I got to do step 3, fill the octet of the outer atoms. And if you haven't noticed, I like to go from left to right. So I'm going to go ahead and do that. I have 12 to work with. So 1, 2, 3, 4, 5, 6, right? So I have 6 left. So then now I go over here, 1, 2. And what I mean by left to right, that means like the outer atoms, right? This is a central atom. We kind of leave that one to the end. So 1, 2, 3, 4, 5, 6. Now I have 0. Okay? So I have no more to work with. Now I got to see if everybody's happy. Happy. 2, 4, 6, 8. 2, 4, not happy. 2, 4, 6, 8, happy. So remember, molecules become happy because they share electrons. So if one is not happy, it has to share from another atom, right? So I can bring these in. So I do that. I'm going to erase these, right? But I'm only erasing the top one, and I bring that in. Did that solve my problem? 2, 4, 6, 8, happy. This one, 2, 4, 6, still not happy. So what I have to do is bring these in. Okay? Now, is this carbon happy? 2, 4, 6, 8? Yes. And that is the structure for CO2. I subtract these, 2.55 minus 3.44. I get 0.89. That is between 0.40 and 1.99, so it's polar covalent. I'm going to draw the dipole towards the one that's more electronegative, which is the O. So I'm going to point the arrow towards the O for each one. And that is my structure. Now we move on to the next one, C3H8. One of the things that I notice with students struggling is they don't take into consideration like what these numbers mean. This means that there's 3 carbons, and this means that there's 8 hydrogens. Students understand that concept when they're doing this part. They're like, oh, Mrs. Angeles, this has 3, this has 8. They're okay with that. But they're not okay with drawing what it looks like over here. So let's first take the time to figure out the available electrons. Carbon, right? 3. So carbon has 4 because it's in group 4. So 3 times 4 is 12. Hydrogen has 1. 8 times 1 is 8. So it has 20 to work with. Okay? So this is what I'm talking about. Students struggle with this. Like, what does this mean, C3H8? That means that there has to be 3 C's. 1, 2, 3. And then this means that there has to be 8 H's. So then I'll have students say, oh, well, I could probably fit them in the middle. But remember, you can never put more than one thing attached to H because it can only hold 2. So never put them in the middle. So what that means is that they have to go on the outside. So 1, 2, 3, 4, 5, 6, 7, 8. And it can't be a molecule unless they're attached. So I got 20 to work with, right? And now I'm going to attach them. I attach the C's all across, and I have to attach my H's. So let's see how many we've used. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I have 0 left. I've used all available. Now I got to see if everybody's happy. All the H's are happy because they can only be attached to something, right? But let's see if the carbons are happy. 2, 4, 6, 8, happy. 2, 4, 6, 8, happy. 2, 4, 6, 8, happy. So this is the structure. Now, I gotta look at the electronegativity. 2.55 minus 2.20 is 0.35. That is less than 0.40, so it's nonpolar covalent. Now let's do HCN. So, remember, 1 H, 1 C, 1 N. H, C, N. There's one of each. H has 1 valence electron, 1. Carbon has 4 because it's in group 4. Nitrogen has 5 because it's in group 5. 1 plus 4, 5 plus 5 is 10 available. Okay, what should I put in the middle? Well, I can't put H in the middle, so I can either put C or N. C has a lower electronegativity, so C goes in the middle. So I'm going to put H over here, N here. I have 10 to work with, and I need to connect them. That's step 2. 2 plus 2 is 4. 10 minus 4 is 6. Okay, so I have 6 to work with. I'm going to start on my left side. Can I add any more to this H? No, it's already happy. It has its 2. Once I attach H to an atom, I check it, it's happy, I cannot put anything on there. So I go to the other outer atom. 1, 2, and I'm going to draw these lightly, okay? So 1, 2, 3, 4, 5, 6. Now I have 0 left. Last thing I got to do is see if everybody's happy. I already know this one's happy. 1, 2, 3, 4, not happy. 1, 2, 3, 4, 5, 6, 7, 8, happy. So then students now have to decide, how am I going to make that carbon happy? Because H and N are happy. H has no more to share, so they have to come from here. So I'm going to erase these and bring them in as a double bond. Let's see if that solves my problem. Is this carbon happy now? 1, 2, 3, 4, 5, 6. No. I got to bring this one in. And now it's happy. Is this N happy? 2, 4, 6, 8? Yes. So now that structure is complete. Why do I have 2 electronegativity differences? Because there's a H to a C and a C to an N. Do you guys see that? Okay. So now when I subtract these 2, I get 0.35, which is nonpolar covalent. When I subtract these, I get 0.49, which is polar covalent. So now I can see that the N has a higher value. So I'm going to put my arrow towards the N. So it's going to look like this. So we are officially done with notes. Here is the homework. It says bonding 1. Notice how it is one-sided. Okay? Looks just like the notes that we just did. Make sure that you recognize that this is Cl2. It is not Ci2. So essentially what you're doing is saying that Cl has 2. Okay? Don't overthink it. And then here you got to figure out the electronegativity, subtract them just like how we did in the notes. Do your drawings here, and you have to upload this by 8 a.m. tomorrow. Okay? If you have any questions, feel free to email me.